Deep within the heart of our planet, a molten iron core spins like a colossal dynamo. This churning mass generates a powerful magnetic field, an invisible shield that envelops Earth and stretches far out into space. This magnetic field, our planet's own personal force field, is far more than just a scientific curiosity. It's our silent guardian, protecting us from the relentless bombardment of harmful radiation that constantly streams from the sun. Imagine, if you will, a stream of tiny, supercharged bullets constantly fired at Earth from a cosmic machine gun. Without our magnetic field, this constant barrage would strip away our atmosphere, leaving us exposed to the harsh radiation of space. Life as we know it would be impossible. But thankfully, our magnetic field acts as a shield, deflecting most of these harmful particles away from Earth, allowing life to flourish. Think of it like an umbrella protecting you from a downpour. And every so often, something truly remarkable happens. The magnetic poles, the points where the magnetic field lines converge at the North and South poles, decide to switch places.
This dramatic event, known as a geomagnetic reversal or a pole shift, has happened countless times throughout Earth's history. It's a natural part of our planet's magnetic cycle, though the exact cause is still a subject of scientific study. Imagine two dancers gracefully swirling around each other, their movements dictated by an invisible force. This is akin to the relationship between Earth's magnetic poles. They're in a constant state of flux, influenced by the complex dynamics within our planet's core. Over thousands of years, these poles can wander far from their geographic counterparts, the points that mark the axis of Earth's rotation. In fact, right now, the magnetic North Pole is drifting towards Siberia at a rate of about 34 miles per year. The magnetic field weakens, the poles begin to wander erratically, and then, in a geological blink of an eye, they flip. North becomes south, and south becomes north. During this transitional period, the magnetic field weakens considerably, losing perhaps as much as 90% of its strength.
Today, we live in a world shaped by Earth's magnetic field. It guides the migration of animals, from birds soaring high in the sky to whales navigating the vast oceans. It influences the stunning auroras that dance in the polar skies, dazzling displays of light caused by charged particles interacting with our atmosphere. And it underpins our modern technological infrastructure, from the GPS systems that guide our cars to the satellites that beam information around the globe. As we speak, the magnetic North Pole is on the move, and the strength of our magnetic field is slowly but surely declining.
Section 4, the big flip. What to expect. The good news is that a pole reversal, while a significant event, is not a doomsday scenario. Life on Earth has weathered countless such flips throughout its long history, and there's no reason to believe this one will be any different. During the transition period, as the magnetic field weakens, we can expect to see more frequent and intense auroras as charged particles penetrate deeper into our atmosphere. These celestial light shows will be visible far beyond their usual polar haunts, perhaps even gracing the skies above the equator. Our technology, however, might be a different story. Satellites, particularly those in low Earth orbit, could be more vulnerable to damage from solar radiation. Scientists are constantly monitoring Earth's magnetic field, and with sufficient warning, we can take steps to mitigate the risks posed by a weakened magnetic shield.
Section 5. A new magnetic landscape. Once the flip is complete, we'll find ourselves living in a world with a reversed magnetic field. Compasses, if they haven't been recalibrated, will point south instead of north. Migratory animals might experience some initial confusion, but over time, they'll adapt to the new magnetic landscape, just as their ancestors have done countless times before. The auroras will return to their usual haunts near the poles, though their appearance might be different, shaped by the altered magnetic field lines. The study of geomagnetic reversals provides us with a unique window into the inner workings of our planet, allowing us to piece together the history of Earth's magnetic field and its impact on life over millions of years.
Section 6. The future of our blue planet. The impending pole shift, while potentially disruptive in the short term, is ultimately a natural and inevitable part of Earth's magnetic cycle. It's a reminder of the awesome forces at play within our planet and the interconnectedness of life on Earth with the cosmos. By studying these events, we gain a deeper understanding not only of our planet's past, but also of its future. The more we understand about Earth's magnetic field, the better equipped we'll be to protect our technological infrastructure, safeguard our planet, and ensure the continued flourishing of life on this pale blue dot we call home.